problem we want to look at is the problem of finding all points on the x-axis that lie at a distance 6 from the point 4, -3. Now we are always well advised to make a sketch, so we're going to make a sketch here. And the point 4, -3 lies at 1, 2, 3, 4 units to the right on the x-axis, 1, 2, 3 units down on the y-axis. So to make sense of this question, we need points on the x-axis that are 6 units of distance from 4, -3. Now let's get the idea of 6 units of distance from 4, -3. From 4, -3 we could go to the left 6 units. That would put us, if we go over here, 4 units and 2 more, that would put us here if we went directly to the left. If we went directly to the right, well, that would put us out at 10 units. And I'm not going to mark all those units. If we went down, well, that would put us at 4, -3 down here, and up here it would put us at 4, 3. So these arrows are all 6 units. So I just put 6's on them to indicate that they're all 6 units. And even more generally, all the points that lie at 6 units lie on a circle of radius 6 around this point. So we could even attempt to sketch a decent circle. Okay? Not a very good circle. But we can see, among other things, that that circle is going to intersect the x-axis twice. So now that we see that the circle, that the points at distance 6 from 4, -3, that there are 2 points on the x-axis that are at that distance, we go about trying to find the points. Okay, now off camera, I drew this picture, same as this picture, but we don't want to clutter it up with all the arrows and the circle and everything. We have the point 4, -3, and as we've seen up here, there's a point probably to the left of the y-axis, but our solution will tell us for sure whether that's the case, and a point out here further along the x-axis, and these points each lie at distance 6 from the point 4, -3. Now a little more picture helps. Anytime we have 2 points like this, we're asking questions about distances or slopes. We want to draw, excuse me, get choked up when I talk about the Pythagorean theorem, can't even pronounce it. Okay, we want to draw a right triangle with a horizontal and a vertical side. In other words, a leg parallel to the x-axis and a leg parallel to the y-axis. We can do the same thing over here. I don't want to draw the triangle like this. Wouldn't be any harm in it, but it would interfere with my labeling of the 4 - 3, so we'll just draw the triangle up here. Okay, so what do we know about these points? Well, we know that each of these points has the coordinate, y coordinate is 0, the x coordinate is x. So if, for example, this point is x 0, then what's the distance of this point from 4, -3? Now we know it has to be 6, but let's get the expression for the distance. So the distance from 4, or between 4, -3, well, from 4, -3 doesn't matter, to x 0 is what? Well, if we understand the Pythagorean theorem, we know that this leg is just 3, because we're at -3 here, we're going to go up 3. What's this leg of the triangle? Well, that's going to have a length that's equal to either x - 4 or 4 - x. In this case, the length would be 4 - x, since x is less than 4. So we can write this equation. Of course, the Pythagorean theorem says, well, this is 4 - x, this is 3. So the Pythagorean theorem says that this distance is the square root of this squared plus this squared. So that's 4 - x quantity squared plus 3 squared. Now, assuming that x is at distance 6, that distance has to be equal to 6. So now we have an equation we can solve for x. Now before you look at what I've written up here, and I'm kind of intentionally standing in the way so you're not as tempted as you might otherwise be, see if you can solve this equation. Now, hopefully pause and try to solve that equation, but here it is. I've written it again. From here to here, what have I done? Think about what I've done. Get your own answer. Well, I've squared both sides of the equation, taking in the square root, of course, will go away when I square it, and the 6 will become 36. Now we want to solve for x. We could expand the 4 minus x. We get 16 minus 8x squared, minus 8x plus x squared with 3 squared and all that. And we could get a quadratic equation, use the quadratic formula. But there's a much more direct way to solve this. Nothing wrong with doing what I said, but there's an easier way. And that's simply to rearrange the equation as 4 minus x quantity squared equals 36 minus 9. Now I kind of skipped a step here. Well, 3 squared is 9. If I want to get the 4 minus x quantity squared on one side, then I'm going to have to subtract 9 from both sides. And I get 4 minus x quantity squared equals 27. Now, what's the simplest thing I can do to this equation? Again, I could square that 4 minus x at any point, get a quadratic equation. Maybe I could factor it, maybe I can't, but the quadratic formula would tell me everything I need to know. But I have something squared equal to 27. To find out what that something is, all I have to do is take plus or minus the square root of 27. Because remember, when something is squared, if the square of a quantity is equal to something else, then that quantity is going to either be the square root of that something else or the negative square root of that something else. So this gives us 4 minus x equals plus or minus the square root of 27, which equals plus or minus 3 times the square root of 3. So now we get x. We can solve this for x. We're going to get actually 4 plus or minus 3 square root of 3. Now, of course, we have minus x here. When we subtract 4 from both sides, we're going to get minus 4 over here. So what happened? Why is the plus minus still plus minus? Well, it really isn't. We could say it's minus plus, but it doesn't make any difference. Either way, we're going to have 4 plus 3 square root of 3 or 4 minus 3 square root of 3. So there's our solution. X equals 4 plus 3 square root of 3. X equals 4 minus 3 square root of 3. Now, square root of 27 is a little over 5. That's about 5.2. So 3 times the square root of 3 will be about 5.2. So this is going to be approximately 9.2. This is going to be approximately negative 1.2. Do those numbers make sense with this picture? Okay, well, the negative 1.2, well, my circle wasn't very well drawn. I did have an x, I did have a point between negative 1 and negative 2. And out here, is that plausibly equal to 9.2? Yeah, it's plausible. If you take out a meter stick and measure everything to scale, you'll find that it isn't all that accurate, but it's in the right ballpark. So these solutions make good sense in terms of the geometric situation. I'll note that you didn't need these pictures really. If you use the distance formula, you will find that the distance between 4, negative 3, and x0 is quantity 4 minus x squared plus 3 squared. And you might have x minus 4 squared here. Since it's squared, it doesn't matter if you have 4 minus x or x minus 4. So you'd have distance formula gives you this expression for distance and this expression for distance, which would then be solved by exactly the same steps. For most people, the geometric picture is very helpful to solving a problem of this nature. If you want to memorize the distance formula and use it, it's not forbidden, but many problems could well ask you to interpret the situation on a graph, so you need to be prepared to do that. So I recommend that you start with the graph, do as much as you can with the graph. One way or another, you're going to end up with this equation and you're going to need to solve it.